Right, now let's start with the easiest one first. When n is equals to 0 and a is a positive number, greater than 0 just means it is a positive number. So for example, when a is a positive number, let's say it is equals to 3. And we have 3 times x to the power of 0. The power is 0. So what do we have as the graph? Any idea? Well, do you realize that this is actually a very simple... Y equals to what, Afiq? Y equals to 3, right? This is y equals to 3. Wow, so thick. Okay, then does everybody know how to draw the line y equals to 3? Or 1? Is it a straight line? Okay, what kind of straight line is it? Diagonal, vertical, horizontal? Horizontal? Horizontal, yeah? Okay, so I want you to draw with ruler and pencil. X and Y axis. Come on, hurry up. Everybody should have your pencil, your ruler. Yes, use pencil. What if you use a pen during an exam and then you make a mistake? Then how are you going to draw again? Then your front cover says do not use correction tape, right? Okay, so the graph should look like this. One horizontal line. Show me the intercept. In this case, it is 3. And write down the equation of the line. Y equals to 3. Those of you who are already done with this, you can move on to the one on the right hand side. You can try it yourself. Wei Hao, have you drawn it already? Have you drawn it already? What's taking so long? Yes, do the second one. Y equals to negative 2 x to the power of 0. So what do we have over there? What n? Because later on in the next row, we will see what happens when n is equals to 1, n equals to 2. And subsequently, n equals to 3. So what's this? Negative 2 x power 0. How much is that? Negative 2. So again, your x and y axis with ruler. And we will have a line, again horizontal, but below the x-axis. Whenever you draw a graph, you must label it. Because very often, we will ask you to draw many graphs on the same x and y axis. If you do not label, but you get the correct graphs, you will still get 0. Because I don't know which graph is for which one. Maybe you were lucky. Maybe you didn't know which graph belongs to which equation. Then you just try your luck. See whether the teacher will not notice or not. Too bad, we will notice. And you will get a 0. So you always must label your graph. Okay, I'm moving on. Next one. Now we have the coefficient of x, positive again. In this case, I chose 4. And the power of x is 1. What do I get? This is actually the same as y equals to 4x. Do you know how to draw the graph of y equals to 4x? Is it going to be a straight line? Yes or no? How do we know for sure it is a straight line? Because what? The front? Come on, hurry up. Say what you said. I want to hear what you said. No, tell me what you said. What? Okay, then it's wrong. We know it is a straight line because it is of the form y equals to m mx plus c. Where is the m? Yeah, m is the 4. What about the c? This is 4x plus 0. So what is the gradient? What is the gradient of this line? 4. The gradient is 4. What is the y-intercept? 0. Okay, so since the gradient is 4, is it sloping upwards or downwards? Upwards. And you'll pass through this point. You'll pass through 0, 0. So y equals to 4x. This is 0 over here. One straight line. Wait. This is of the form y equals to mx plus c, correct? Where c equals to 0. Do you agree? Sophia agree? Roberto agree? So if it is y equals to mx plus c, it must be a straight line, right? Agree? If it is a straight line, then we need to know how it slopes, whether it slopes up or slopes down. And that is given by the sign of the gradient. Gradient is positive. In this case, it's positive, so slope up. If gradient negative, which we will see later on, it will slope down. And then we also need to know where it passes through. Where is the y-intercept? In this case, the y-intercept is 0. So you'll cut the y-axis at 0. That's why I'll pass through this point. You mean the gradient is 4? Yeah, because I didn't show you the scale of my x and y axis. So if you had drawn it this way, something more steep, like that, but straight line lah. Mine a bit curved. Okay, if you draw this, it is still okay. Y equals to 4x. As long as I say it is positive, a graph, a straight line sloping upwards, I will take it that it is correct. Okay? Any other questions? Okay, then let's move on to the next one. Y equals to negative 5x to the power of 1. This is the same as y equals to, whoa, what is this? Oh no. Oh, okay. Pen. Y equals to negative 5x. So is this a straight line again? Yes, it is a straight line, plus 0. So what is the gradient? Negative 5. How is it sloping? Okay, what is the y-intercept? Good. So with all this information, we can draw it already. Label your axis, x and y. And a line sloping downwards, passing through 0. Y equals to negative 5x. One straight line, I am obviously not using a ruler. Yes? Okay, can I move on? So far very easy, Okay. That is something that we learned in a previous topic, previous chapter, chapter 8. When n equals to 2, the power is equals to 2. So we have x squared. And my coefficient of x squared, in this case a, is a positive number. What am I expecting over here? What shape? What shape am I expecting? Straight or curve? Curve, because it is no longer y equals to mx plus c. Here I have x squared. So it must be a curve. What kind of curve? What kinds of curve have you learned? Yeah, I don't like the smiley face. I call it a parabola opening. Either upwards or downwards. How do we decide whether it opens up or down? We look at the coefficient of x squared, whether it is positive or negative. Okay? Since it is positive, we know that it is going to be a parabola opening upwards. And a parabola must be symmetrical. And it must keep opening upwards. So the shape will look something like this. And if I draw it in with my x and y axis, it will look like this. Okay, to answer that question, we can plot in some numbers, x and y. Okay, let's try -3, -2, -1, 0, 1, 2, and 3. Can you quickly help me find out what is the value of y when x is equal to -3? Am I correct? Am I correct? Am I correct or not? Yes? No, it goes on forever and ever. I just choose to start at -3. Roberto, do you try calculating? Are these numbers correct? Okay, so let us plot. When x is equals to -3, what is my value of y? 54. Okay, let's say 54 quite a big number. Let's say it is over here. Okay, this is my first point. Then -2, -1, and 0, 1, 2, 3. So these are the points that I plot so far. -2 and 24. 24 is less than half of 54, isn't it? So a bit less over here, 24. This is a sketch. If you use your graph paper, you will be able to draw a very nice parabola. When it is equal to -1, I have 6. So that's about 1/4. So over here, 6. And then 1 point over here. And since it is symmetrical, can you see that the values over here are the same as those over here? That's why it is symmetrical. So this is 6 again. Then 24. And the last one, 54. So now I have a total of 7 points. I'm going to join them up to get my parabola. Okay, join everything up. Okay, if you draw a smooth curve, then you will get a shape like this. Parabola opening upwards. Roberto, have I answered your question? Why is it opening upwards? Okay, so then, based on this example, based on what Roberto asked, do I need to memorize how the shapes look like? Why don't it? But that still requires you to memorize what? If you forget how, then plot lor. Plot all these things out lah. Once you have all these things, you can do a rough sketch, right? It didn't take me too long, so I expect you to work fast and to be able to do this as well. Best is if you can memorize it. That, like earlier on, we don't need to plot this, right? We don't need to plot our x and y values. Then we plot, and we get a straight line, right? We already know how to do it. So likewise, it will be good if we can memorize that y equals to 6x squared will give me a parabola opening upwards. Okay? What's missing from my graph? My equation. I must write down the equation. Y equals to 6x squared. Can? Okay. Any questions? Then the last one. Y equals to -3x squared. What shape are we expecting? Shape. Parabola. Opening downwards. It's going to look like this. Okay, not symmetrical. Still not symmetrical. Okay, that's a bit better. So, right now, I can choose to plot the values again. But I don't want to waste time. because I already know what it's going to be like. So draw your y and x-axis. It is going to open downwards and it is going to pass through the origin. How do I know? Because if I just do a quick substitution, x equals to 0. When x equals to 0, y equals to 0. So I know it is going to pass through this point. This is actually my maximum point. And my graph is going to open downwards. Okay, so this is y equals to negative 3x squared. Must be symmetrical. When I ask you to sketch, you do not need to plot. That means you don't need a graph paper. Sketching just like this is enough, showing me where the intercepts are. In this case, it is intersecting the x and y axis at 0, 0. So there we have it, all my graphs. Quite easy, huh? Or who is not done drawing it? Okay, then I'll show you some negative examples of parabolas. Have I shown that with you before? I might have. Bring what? Okay. Remember I told you about the shape of parabola? So I want you to tell me right now, is this a parabola? Because it looks like two straight lines, right? What if so this not, what if I try to curve it a bit? What's wrong with this? This part? What's wrong with it? Very sharp, huh? Okay, so you see, you can recognize something is wrong over here, but you don't have the correct vocabulary to describe it, right? We will be using this term called gradient to talk about this point subsequently, later on in the chapter 9 at the back. We will talk about gradients of curve. Last time, we only talked about gradients of straight line, right? Gradient of straight line, if it is positive, this positive gradient, this negative gradient. This is very steep positive and even steeper positive gradient. And then this is negative, even more negative gradient, isn't it? These are all straight lines only. Later on, I will teach you about how we describe gradient of a curve. But don't worry about that first. Just keep in mind that all of you already have some idea of what a gradient of a curve is like. Just that you don't know how to use it, you don't know how to use the word yet. Later on, we'll teach you. Okay? So now, I want you to, in your notes, right? This piece of paper, turn to the back. There's blank, right? I want you to copy this down. Same thing, divide it into half, left and right, when n equals to 3 and a is greater than 0. Example, y equals to 2x to the power of 3. Then on the other side, when n equals to 3 and a smaller than 0. Example, y equals to negative 4x to the power of 3. Okay, copy these two down. Because this is the last case that we're going to be talking about. We have learned power 0, power 1, power 2. Now we are going to finish it up with power 3. Okay? All copied already? Don't use up too much space in your back page. Just the top 1/3 will do. Okay, now I am going to let you try, because right now you don't know what the shape looks like, right? So let's pretend that this is an exam. I ask you to sketch y equals to 2x power 3. Then you don't know how to do it. You can't remember the shape. What are you going to do? Yeah, you plot. Okay, try plotting now. Try plotting now. Draw a table. X, y. Try -3, -2, all the way until 3. -2, -3, -2, -1, 0, 1, 2, 3. Find the x and y values. Then plot it out. Once you're done, go on to the other graph as well. Just use the top 1/3 of your paper is enough. Don't need to be very big. Then, although it is a sketch, try to scale it properly. If, for example, you need to go to -54, then the spacing for -54 must be much, much greater than the spacing for -16, for example. What's the power now? Power is 3. Do you all get these values? Yes, okay, so I don't know why quite a number of you, after you get a table, right, then you refuse to draw your graph. You have your x and y axis already. Don't worry. Try to sketch it as accurately as you can. -1, -2, -3 here, right? Here we have 1, 2, and 3 on my x-axis. When x is equals to -3, what is my value of y? -54. Wow, very low here, -54. Okay, so 1 point over here. What is the next value? -16. Okay, it's gonna be smaller, maybe over here. -16. So another point here. What about when it is -1? Then I have -2. Let me just use red color. -2 over here. Okay? So far okay, my red crosses now. Do they make sense to you? Then on the other side, when x is equals to 1, when x is equals to 0 first, y equals to 0. One more point over here. When x equals to 1, it will be 2. Over here, 2. When x equals to 2, it will be 16. So over here, 16. And finally, 54. For x equals to 3. Can? Then now, I am going to join them up. Do you have a straight line? Yeah, it's like this weird shape, right, Xiao Wei? Right? What do you draw, Xiao Wei? You drew a parabola. It's not a parabola. It looks like this. Here we are. Okay? It is a curve. Okay? If your plot doesn't look like it, you can plot in more points. You can try when x equals to -1.5, when x equals to -2.5. Then you will have more crosses to work with. And you will have a better idea of the shape. Okay? Any questions on this? What is this? What does this shape look like? Looks like a worm, like a snake. Look like what? Saber. Okay, whatever it is that helps you remember, okay? Your x cubed graph looks something like this. Then what about the other one? When y equals to -4x to the power of 3. Can we try that? Try and plot in some points. This one is y equals to 2x cubed. Yeah, n is the power over here. the end, you should get something that looks like this. Okay, you should get it straight. Hey, when practice drawing a graph, it should not be straight line and straight line and straight line. It should be a curve, a smooth curve. Exactly how the graph will look like. Okay? Those who have not plotted, you can just copy down the shape that I have over here. Smooth, and then go down. Okay? Then now, I want you to compare what I have in green color with the next graph I'm going to draw over it in red. Now I'm using red to show you that this is wrong. Okay? So I'm showing you a wrong graph now. What's wrong with this red graph? This part here look like a straight line, right? Okay, so that is wrong. Does it look like kind of symmetrical? Okay, you look at the green one, The green one, do they look kind of symmetrical? Like this curve over here, I can rotate it and then it will be the same curve over there, right? It is meant to be that way. So when I draw my graph, I cannot have one that is very curvy like that and then one that is like that. Because when I rotate this portion, it is not going to give me the part on top. So this is also wrong. Okay, the final example that I'm going to show you that is wrong looks like this. Yeah. Okay, so what's wrong with this red one? I'm just going to give you a bit of extra information about gradient of a curve. When I want to find the gradient of a curve, I need to draw a tangent. Anybody heard of a tangent to a curve before? Not exactly the Tokaso thingy, but a tangent to a curve. Let's say I want to find a gradient of a curve. You don't know how to do that. You only know y2 minus y1 over x2 minus x1. That is for a straight line. So if I ask you to find the tangent of a curve, you need to draw one straight line that touches the curve at whatever point it is. So for example, if I want to find the gradient at this point, I need to draw a straight line over here that touches the curve at this point only. Okay? Then I draw a straight line and I find the gradient of that straight line. Meaning, at different parts of this green curve, I've got different gradient. Because you imagine, if you are climbing down this slope, some parts steeper, some parts not as steep, right? This part here very steep, this part not very steep. How do we use mathematics to describe the steepness? We use gradient. So my ruler right now is going to demonstrate what the gradient looks like at different points of the curve. Right now the gradient looks like this, very steep. As I move along the x-axis, my gradient changes. It is now less and less steep. You see? What happens to the gradient at 0? At the origin. What is the gradient over here? What is the gradient of a flat line? 0. The gradient over here is 0. Okay? Then as I continue, now the gradient increases again. Or rather it gets more and more negative. You see how the gradient changes? It is like a roller coaster ride like that. Okay? Now, that brings me to my point. What is the gradient of this red curve at this point? Is it one horizontal line or does it look like this? Number 1 or number 2? Number 2, right? So that is the error that many people make. Hang on. That is the error that many students make when you draw your cubic graph at the origin. Many students tend to draw the gradient as this, when it should actually be 0. Okay? I'm going to show you earlier on what you guys told me about the quadratic graph. Look at this one. What is the gradient at this point over here? It is too sharp. I cannot get. Is the gradient supposed to be like this? Is the gradient supposed to be like this? Is the gradient supposed to be like this? I can't tell because it is very sharp. What should it have been? It should have been a very smooth curve, looking like this. Now over here the gradient is 0. You see? Whereas I compare it to a very sharp point, I'll have either a positive gradient or a negative gradient. Then I cannot make up my mind. That is the problem with this graph. Okay, the gradient at the origin is not 0. I need it to be 0. So this is wrong, this is correct. In the same manner, for my cubic graph, over here, the green graph has a gradient of 0, whereas the red graph has a gradient of not 0 at the origin. That's the problem. Okay, so check your graph. Does it look very flat at the origin? If it does, good for you. You got it correct. If your graph looks like it is not flat over here, it is more like a diagonal line, then it is wrong. Okay, check your graph now. This one and this one. They are both supposed to be very flat. This one I didn't draw it very well. It should have been flatter. Okay, check your graph. If you are not sure whether it's acceptable or not, raise your hand. Wait, no good. What's this? Not accepted. Draw again.
Draw again.
Yours also cannot lose actually. Okay. So in summary, for what have we covered? But what are the powers that we have covered? When power is 0, we will get, for example, y equals to ax to the power of 0. We will get a horizontal line, and it cuts through a. So this is y equals to a. Okay? Then when we have y equals to, okay, this is a greater than 0. When y equals to ax power 0 again, but this time a is smaller than 0, then I'll have this line, y equals to a also, but it is below the x-axis. Is this part confusing or not? The a positive, negative part? Not confusing. You can actually replace them with numbers yourself. For example, over here, a could have been maybe equals to 3, for example. Maybe over here it could have been negative 3. Okay? That is for y equals to ax power 0. Then recap, y equals to ax power 1, where a greater than 0, and y equals to ax power 1 again, but this time a is smaller than 0. So I will get over here, can you see what I'm trying to do? Cut through the origin. Okay, so this is y equals to ax. And over here, because a is smaller than 0, I'm getting a gradient sloping downwards. It's y equals to ax again. So for example, this could have been equals to 2x, y equals to 2x, for example. Over here, this could have been y equals to negative 3x. So it slopes downwards. Okay, you're very familiar with these two. Then we have our y equals to ax to the power of 2, where a greater than 0, as well as y equals to ax power 2, but a smaller than 0 this time. So what kind of parabola do I get for the first one? What kind of parabola do I get for this? Opening upwards. Okay. So the tangent at the bottom, see, it is a gradient that is flat. So this is my graph of y equals to ax squared, where a could have been, I don't know, maybe 4x squared. Okay? A could have been 4. And then on the other side, I have y and x. This time it is opening downwards. So the graph will be y equals to ax squared. For example, it could have been negative 3x squared. Your graphs will look like this. These are just sketches. And of course, the last one, which you have just tried, will be y equals to ax power 3. A greater than 0. Again, y equals to ax power 3, but a smaller than 0 this time. Okay, I want you to watch how I draw it. I do not start from this side, then I draw this way. Instead, I start from the origin, because I said before, the origin is very important. How it slopes, what the gradient is like, what the steepness is like at the origin is very important. It should have been flat. So I try to make it flat first, then I go up. Okay, let me draw it again. Okay, you see, flat at the origin, as flat as I can. Then on the other side, it must look quite symmetrical. Like I rotate this 180 degrees. Okay, then I'll get something like that. Okay, so this is y equals to ax power 3. For example, a could have been 5. So for example, y equals to 5x power 3 will look like this. Smooth curve. And on the other side, since my a is smaller than 0 this time, it is going to look like this. I start from the origin again, slope downwards. Okay, then the other side, slope upwards. Make sure they are continuous. So this is y equals to ax power 3. For example, it could have been negative 4x power 3. Okay? Yes. Afiq has the correct idea. Did you all hear what he said? He said, can I draw a full parabola? For example, y equals to 3x to the power of, no, let's make this 5x to the power of 3. If I ask you to draw this, so Afiq is suggesting that instead of drawing like that, can he draw a parabola? Like that? Like that? Then he erased this part. Yes, you can. The shape is like a parabola. Then can he, for the other side, can he draw a parabola opening downwards? And then he erased this part? Yes, he can. And he will get the correct shape. Okay? So the similar thing can be done for negative 5x to the power of 3. Then it will just be the other way around. Okay? Yeah, okay. So that's all for our positive powers. You mean like this, is it? You mean like that? Like, it touches like that, is it? Can. It's okay, but you don't go and make it, don't go and draw very far, from here, wow, you draw very long, then you come out, then you cannot. Okay? Because by right, when you zoom in, you zoom in and you zoom in, it won't stay on the x-axis for very long. Just a little bit only. Okay? If you zoom in and zoom in. Okay? So we have covered power 0, 1, 2, 3. So what's next? It's not 4. We are going to learn negative. Negative 1 and negative 2. Okay, Irfan? Okay? Negative 1 and negative 2 are. So the same method can be used to determine what the shape looks like. But right now, I will spare you the effort of plotting again. So remember at the back of your page, I told you to use 1/3 only, right? The top part. Now the second 1/3, this is what I want you to do. Y equals to ax to the power of negative 1. Sorry. Let's use the same format. When n equals to negative 1, a greater than 0. So example, y equals to 3x power negative 1. Then on the other side, when n equals to negative 1, a smaller than 0. Example, y equals to negative 3x power negative 1. Okay, we have seen positive and 0 powers. Now, we're going to go into... What time your lesson? Okay, 5 more minutes. We shall go into negative powers. So negative 1, if you go and plot it out, you'll realize that the graph looks like this. Y, x. Okay, what is so unique about this graph? Does it look like it is 2 graphs? It looks like it's 2 graphs, right? How come all our other graphs we have one smooth line, but right now I have 2 different parts? Why? Can anybody come up with a reason why it has 2 parts? Zafira says it doesn't intersect. Doesn't intersect what? It doesn't intersect your x-axis, it doesn't intersect your y-axis. You notice that, did I draw them touching? They are not touching. What if I zoom out? When I zoom out and I zoom out, they will never ever touch. It will never ever touch your x-axis, it will never ever touch your y-axis. Although it looks like it is going closer and closer to the x and y-axis. So the question is why, right? Yes, Francis, what's your question? It is not straight. It goes closer and closer but it doesn't touch. So no, it's not parallel as either. So if I extend this x-axis all the way, and then if I continue drawing my graph, it is going to go closer and closer and closer. Cannot touch. You cannot touch. Yeah, because my drawing is not good enough. It is supposed to go so close, it looks like it's touching, but it cannot touch. You know why? Yeah, even if you go on and on and on and on, you also never touch. Yeah, okay, why? Very good. Do you think I know the answer? Yes, I know the answer. What happens when y equals to 0? Because if you say it touches the x-axis, touch x-axis, it means y equals to 0, right? What happens when I substitute y equals to 0 here? So 0 equals to 3x power negative 1, right? Which is actually 3 over x, correct? What is x equals to? So, what is x equals to? If I ask you to solve this equation, 3 over x equals to 0. What is x equals to? Sure or not? You go and press your calculator, 3 divided by 0, what do you get? What is the value of x if I ask you to solve this? Undefined. There is no answer. That means your y can never ever be 0. Because when y is equal to 0, you don't have an answer for x. Yeah, no solution. It doesn't touch your x-axis. Okay? Well, straight away what? When you see this question, they ask you to draw it. You cannot let your graph touch the x-axis. That's it. Okay? And I am going to use the same explanation to tell you why it cannot touch the y-axis. Okay? Can it touch the y-axis? Okay, let's try. When it touches y-axis, what does that tell me? What is the x value? X equals to 0, right? When x is equal to 0, y is equal to 3 times 0 to the power of negative 1, right? Which is actually 3 over 0. Can you divide by 0? Can you divide by 0? Then cannot lah. So this is undefined. That tells me that it cannot touch y-axis. No. This is okay. Maybe I change this one. If it touches the y-axis. Okay, if it touches the y-axis. Wait. Let's say we don't know whether it touched or not yet. So if it touches the y-axis, x must be 0, right? So if it touches, x must be 0. Okay, let's see what happens when x equals to 0. When x equals to 0, you realize that y is undefined. Okay, let us try it with decimals. Hey, why you don't believe me? Then you rather believe these decimals. Okay, what is it that you want? Y equals to 3x power negative 1. Oh, no time already. So y equals to 3x to the power of... I don't have power leh. Huh? This one? Oh, this one. Okay. Negative 1. Eh? Zoom out. So zoom out. So, wait. Are you saying it is touching? Who thinks it is touching? Okay, I zoom in over here, okay? Is it touching? It's not touching. It's not touching the x-axis. It is not touching the y-axis. I can go all the way up. Let's try at 5,000. Hey, zoom in. See? Not touching. Okay? So you can draw the line, but you must make sure it doesn't touch. And you also cannot draw it being parallel. Okay? I show you some examples of students who remember what the teacher said. It cannot touch, right? Okay, I draw, cannot touch. Then they draw this for me. They draw this way. Then is it going closer and closer to the x-axis? No, it is not. Over here, they look like they are parallel to the x-axis. Cannot. It must go closer and closer. So what we will draw will look like, okay, this is obviously wrong. It's touching, like that. Okay? No, it doesn't become parallel. It goes closer and closer, but it cannot touch. Not that there's no answer. The answer is it doesn't touch. It just goes closer and closer. Okay, now I am not giving homework for today, but I want those who have not